Hi, my name is Muhamad Fatihi. Ahmad Faizal. I'm from section 1 for SMJE3143 Communication Electronics. Today we're going to look at the analog and digital modulation techniques. So what is a modulation? A modulation is a process where information is being transmitted using electromagnetic wave. It can be either in analog signal or digital signal. So both of these are important to get an efficient and accurate data transmission in a communication system. As you can see here, this is the example of analog signal and digital signal. You can see in the diagram below that analog signal look more natural. The data varies a lot, but digital signal has more fixed values like 1 and 0 because it is used in a binary form, so it is more fixed. It can be used in different applications. We can also change analog signal to digital signal or change digital signal to analog signal. So let's see the modulation process for both analog and digital. So the first type of modulation technique is the analog modulation technique. So this modulation technique would modulate low frequency analog signals into a high frequency carrier signal by altering its amplitude, frequency, and phase. So by using this modulation technique, modulated signal can be transmitted to the demodulator to extract the original signal that we want. So we have three type of analog modulation technique, which is amplitude modulation (AM) and frequency modulation (FM) and phase modulation (PM). But today we're gonna look at amplitude modulation and frequency modulation first. So the signal quality and bandwidth efficiency of the original received signal can depend on the choice of modulator technique we use. So first, let's look at the amplitude modulation. So amplitude modulation modifies the amplitude of the carrier signal in proportionate to the message signal amplitude. So the frequency of the carrier signal will still remain constant in this process. We are going to only modify the amplitude so that it can be transferred to the demodulator to get back the original message signal. So message signal, the advantage of amplitude modulation is that it's simple and it has a long distance transmission, but it is still limited to noise interference. The application of amplitude modulation is in long distance radio broadcasting and many more. First, let's look at the AM modulator. So this AM modulator will combine the message signal with the carrier signal using transistor or diode in the circuit. So the circuit will vary the amplitude of the carrier signal so that the amplitude matches the message signal amplitude. So you can see in the figure here, it is called a ring modulator. So what a ring modulator does, it consists diode, transformers, and filter. This diode is arranged in a ring-like configuration and function as switches. So you can turn on and off based on the input signal. And the two transformer will combine the circuit. The first transformer will transfer the combined carrier and modulated signal into the diodes, while the second transformer will extract the output signal, separating the output signal from the input signal. Now let's look at the AM demodulator. So while AM modulator combine the message signal and carrier signal, AM demodulator will extract the original message signal coming into the modulated carrier. So this is done by using an envelope detector, for example. An envelope detector consists diode, resistor, and capacitor, and this diode will rectify the signal, and the capacitor will filter out the high frequency component and obtain the original message signal. You can see here under here, so that AM signal will be applied into the envelope detector. So using all these components, it will allow positive half cycle to pass through into the circuit and create a series of faults that follows the envelope of the original message signal, so that we can get back the original message signal. Now let's look at the frequency modulation. So frequency modulation will determine the carrier signal frequency as per the message signal, while the amplitude remains constant in this process. And FM is more protected to noise interference than AM, but it requires a lot more bandwidth compared to AM. So FM is mostly used in music and high quality broadcast. So for FM modulator, it produces the frequency required for the carrier signal based on the message signal. We can use techniques such as voltage control oscillator or VCO. It can be able to change the frequency in line with the message signal. So FM signal allow high fidelity audio transmission to be transmitted using radio waves over a long distance. So there are two types of designing VCO. You can use a vector diode or reactant tube. In this case, this diagram here use vector diodes. So a vector diode is a capacitor. Basically, the capacitance will change based on the applied voltage, meaning that it can be tuned in the VCO circuit, and when the message signal is applied, the frequency of the circuit will change according to the message signal. Second, we have the FM demodulator. So FM demodulator can generate AM signal that is the same amplitude as the instantaneous frequency of the FM signal. So using an LTI system that has a frequency response that is approximately a straight line in the frequency band of the FM signal, the original message can be retrieved using an AM demodulator. So AM demodulator, just like before, you can use an envelope detector. So let's look at the digital modulation. Digital modulation is different than analog modulation. In digital modulation, the digital signal is converted by modulating the carrier signal with the digital data signal into a transmitter form. In this presentation, we're going to look at the modulation methods of using amplitude shift keying (ASK) and frequency shift keying (FSK). Digital modulation has a greater accuracy and longer transmitter distance than analog modulation. So in this section, the amplitude of the carrier signal differ depending on the digital data signal in ASK. The frequency of the carrier signal and the phase remain constant throughout the whole process, only the amplitude change. So ASK use low bandwidth and but can be easily affected by noise interference because noise interference can change the amplitude of a signal. So the amplitude of the carrier signal can be adjusted between the range of distinct levels that is based on the binary data 0 and 1. So ASK is widely used in optical fiber communication system and RFID. It is important to use ASK in this system so that the data can be transmitted in high speed. So in ASK modulator will modulate the carrier signal by changing the amplitude based on digital data signal amplitude. So based on digital data, which is in binary form, the ASK modulator makes the carrier signal transmit a high amplitude if the digital signal is 1 and make it in low amplitude if the digital signal is 0. So one example of ASK modulator is diode switching modulator, which is the same as the ring modulator. So for ASK demodulator, it would identify the variation of amplitude that is received and retrieve the original digital data. It's done by using an envelope detector like what we see in the AM demodulator. So let's look at the frequency shift keying. So in FSK, the carrier signal frequency differs depending on the digital data signal, while the amplitude and the phase remain constant. AFK is often requires a larger bandwidth than ASK, but is not affected by any interference because it's characteristic of having a constant amplitude. So AFK is used in wide range of application in the real world, such as radio communication and telemetry. So in FXK modulator, it can modulate the carrier signal frequency based on the digital data signal boundary. So if the digital signal is 1, the carrier signal will transmit at one frequency, while when the digital data is 0, the carrier signal transmit multiple other frequencies. So one way to modulate this carrier signal frequency is by using VCO, where we already seen in the previous FM modulator. So in FSK demodulator, it would detect the variation of frequency in the mixed signal to be able to determine the original data signal. It can be achieved by applying coherent detection method or delay detection method in the FSK demodulator circuit. So in this case, we're using the delay detection method. Delay detection method can use the time delay between different frequencies in the mixed data to get the original digital data signal back. Let's compare and analyze the difference between analog and digital modulation to evaluate these factors of bandwidth efficiency, noise resistance, complexity of circuit design, and practical application. So analog modulation requires more bandwidth compared to digital modulation. This because digital modulation can be packed in a more dense matter that allows it to have a higher data rate even when using the same bandwidth as the analog modulation. Analog signal can be more exposed to noise interference than digital signals. Analog signal represent the data in continuous nature, while digital signal represent data using discrete values that is in binary form. So it is more prone to get affected by noise interference if you are an analog signal. Analog modulation has a simpler circuit design, while digital modulation has a more complex design. Analog modulation can be used in radio broadcasting, for example news and talk shows, while digital modulation can be used in complex applications such as RFID technologies and telemetry. So in conclusion, we have analyzed both analog and digital modulation techniques, principles, characteristics, functionalities, and also its practical application. So when choosing any modulation technique, we need to decide what the application requirements are between complexity, bandwidth constraint, noise environment, and also its functionality. That's all for me. Thank you.